Hello, everybody. Welcome to section 1.3. This section covers polynomials and factoring. So, a polynomial in the variable x is something of this form. So we've got some coefficient an, and we have x to the n power plus a, and then n minus 1, x to the n minus 1, plus dot dot dot, plus a sub 1, x plus a sub 0. Okay, so this is a polynomial. These things here are what we call the terms. Okay, and the largest power, in this case n, is what we call the degree of the polynomial. So, for example, 3x to the fourth plus, or like minus 1/2 x cubed plus, I don't know, maybe the square root of 3x. That's a degree 4, because 4 is the largest exponent polynomial. Cool. So we can combine polynomials with addition and subtraction just by combining like terms. So for example, let's say we wanted to subtract two polynomials like x cubed minus 3x plus 1. Let's say we want to take away from that 2x squared plus the square root 2x plus 8, for example. So how would we do that? Well, I'm going to go ahead and distribute this negative into this polynomial. So then this becomes x cubed minus 3x plus 1 minus 2x squared, right? Because that minus goes into there, then minus square root 2x, and then minus 8. Okay. Then what we do is we're going to collect like terms. So here is a cube term. So that's an x to the 3 term. There's no other x to the 3 terms. So that's good. And then we have an x squared term here. We actually don't have any other x squared terms. And then we have an x term here. And we have one here. And then we have like just constant terms here and here. So what we're going to do is we're going to combine them. So just one blue one, so that stays the same. Just one green one, so that also stays the same. And then we're going to do, minus 3x minus 2x, or minus square root 2x. So we will combine those in the next step, and then plus 1 minus 8, which we'll combine those two in the next step. Like this, we'll do x cubed minus 2x squared. Now I don't know what negative 3 minus square root 2 is, so I'm just going to leave it like this. I'm going to leave them as such and put an x out in front because those are the two x terms. So I pulled the x out here. See what I did? I pulled it out and put it just on the side. And then plus 1 minus 8 is negative 7. So that's the answer. Unfortunately, multiplication with polynomials is a little more complicated. So, for example, let's try a really easy one first. Let's do a 1-degree polynomial, x. So this right here is in fact a polynomial, just degree 1, no coefficient. And then let's multiply it by 2x minus 3, also degree 1 polynomial. So how do we do something like this? Well, we're going to take this x and we're going to distribute it into the parentheses like this. So then this becomes, so we're going to do x times 2x, right, for this first short red line, and then plus x times negative 3 for the second red line there, the longer one. And then if we combine the x's that are multiplying here, this becomes 2x squared plus, or rather, sorry, it's a negative 3, so it's minus 3x. Cool. Let's see something a little more complicated. So let's do x plus 3 times 5x minus 1. And some of you have probably heard of foiling. So, but all foiling is just fancy distribution, right? So you can use FOIL if you want. And for those of you who don't know, FOIL stands for first, outer, inner, last. It's a rule to multiply two 1-degree polynomials like this. Or you can just draw little lines like this. So the x goes to both of those, but then you also need to distribute this 3 to both of them. And the way that works in real life is we get, so this first red line, the shorter one right here, we get x times 5x. And then the second red line here becomes x times negative 1. All right, oops. This first shorter green one right here, that becomes plus 3 times 5x. And then this green line here becomes plus 3 times negative 1. And then if we simplify a bit, we get 5x squared, not plus, sorry. It's a negative 1, so it's a minus x plus, and then 3 times 5, that's 15x, and then negative 3. And then the last step, of course, we have to combine like terms. There's only one x squared term. There are two x terms and only one constant term. So the red one stays the same, 5x squared. The blue ones combine. So this is negative 1, secretly a 1 here. Negative 1x plus 15x is then plus 14x, and then minus 3 stays the same. Cool. Now you can even multiply larger polynomials. Let's see one more example of this. Let's say 3x plus 5, and then let's multiply it by 2x squared minus 3x plus 1. Now this probably looks a little scary, and foiling won't work for it, and that's why I like to draw little lines and distribute just by terms instead of trying to follow the FOIL rules, because those can get tricky, especially when you've got something like with 3 terms like this. So we're going to need to take this 3x term, we're going to have to distribute it to each of these like that. And we're also going to need to take care of this 5 and distribute it to each of those right there. So we get 3x times 2x squared for this first red line. For this second red line right here, we get plus 3x times negative 3x. And then for this third red line, we get plus 3x times 1. And for the green, this first green line is 5 times 2x squared. The second green line is plus 5 times negative 3x. And this last green line right here becomes 5 times 1. Now if we simplify each of these terms, this one here becomes 2 times 3 is 6, and then we've got 3 copies of x, so x cubed, plus 3 times negative 3 is not a positive number. In fact, it is negative 9, and then we've got 2 copies of x here, so we get x squared. Then we have 3x times 1 is just 3x, plus, and then 5 times 2 is 10, x squared, plus 5 times negative 3. I'm doing this every single time, but it is negative 15x, plus, and then 5 times 1 is 5. Now, we combine like terms. There is only one x cubed. Let's see, there's 1, 2 x squared terms. There's 1, 2 just x terms, and then there's one constant term. So we got to combine the colors. So this becomes 6x cubed minus negative 9 plus 10 that's positive x squared. There's secretly a 1 here, remember, right in front, right here like this. But I'm not going to write it just for simplicity's sake. And then plus 3 minus 15, that's minus 12x, and then plus 5. All right, so that's how you multiply polynomials together. But what about going backwards the other way? How do we factor them? And that's actually fairly tricky, factoring. So there's a couple methods you can use to factor polynomials. One of my favorite ones to do, it's sometimes called the trial and error method or the guess and check method, but the name I've heard used the most is the AC method. All right, and that's where you have some quadratic, so this only works with degree 2 polynomials. So if A is just some constant plus some constant B times X plus another constant C, and then it has to equal 0. That's important. What you're going to do is you want to find two numbers. Actually, you want to find two numbers, like a blue number and a red number. And you want to be able to multiply them out to whatever A times C is, and then you want them to add up to whatever B is. That's why it's called the AC method, is because of this right here. All right, and then the answer, once you have red and blue, it'll be 1 over A, and then parentheses AX plus blue number times AX plus red number. Oops. Like that. So that will be the factored answer. Okay, so let's see an example of this action. So let's factor 2x squared plus 7x plus 3 equals 0. So, by the way, if this doesn't equal 0, because it needs to equal 0 for the AC method to work, what you can do is add or subtract the number here to both sides so that this becomes 0, okay? So it has to equal 0 for this method to work. So we want two things. Let's do colors again. Let's do blue, blue, and red, red. We want two things to multiply out to A here is 2, and C is 3, positive 3. So 2 times 3 is 6. And then B, it's right here, it's 7. So we want two numbers that multiply to 6 and add to 7. So how do we do that? A good place to start is by writing out what the factors of 6 are. So we know 6 is equal to, it can be 2 times 3. It can also be 1 times 6. And so these pairs of numbers here are kind of like our guesses, right? And so we can kind of see, if we pick 1 times 6, 1 times 6, that's equal to 6. But 1 plus 6 is not equal, or it is equal to 7, sorry. You've noticed if I tried to choose 2 and 3, right? 2 times 3, that equals 6, but 2 plus 3 is 5, and that's not equal to 7. So that's not what we want. We definitely want 1 and 6 in these slots. So then our answer will be 1 over A is 2, remember, from up here. And then 2x plus 1. And then we've got 2x plus 6. And that's our factored answer. Cool. So there are some polynomials that you look at and you can immediately say, oh, I know how they factor. So there's two main ones that I want you to remember. So these are called special factoring formulas. So the first one is my personal favorite. It's called difference of squares. And it's called that because on one side you have, I don't know, some whatever nasty thing squared minus some other random nasty thing squared. So it's a difference of two squares, and that's just equal to nasty thing 1 minus nasty thing 2. And then that's times nasty thing 1 plus nasty thing 2. So an example of this would be if you had like x squared minus 16, right? So x squared, that's squared. And if you notice, 16 is 4 times 4. So we have x squared minus 4 squared. So then we can easily be like, we know the formula for it. Good. So this becomes x minus 4, x plus 4. The other one that you should know is called a perfect square. And what this looks like, it comes in like two main flavors. So if we have a squared plus 2ab plus b squared, that is going to be a plus b squared. Kind of the same idea. If you have a squared minus 2ab plus b squared, and this is a minus b squared. So to see this in action, if we had x squared minus 6x plus 9, what you might note about this polynomial is that we can write it like this. X squared minus, and then 6 is 3 times 2, right? So we have, I'm actually going to write this as 2 times 3 times x plus, and then 9 is 3 times 3. So we've got 3 squared. Okay? So, oh crap, I forgot something. I am so sorry. There should be a 4 here. So then that's 2 squared, right? And the reason I wanted that is because now we have this 2x, that's all squared, and I pulled the exponent out with our exponent rules. And we have 2x times 3 plus 3 squared. So this kind of follows the formula because you can think of this is kind of our b here, right? And then this here is our a. And so if we follow the formula, this then becomes a, so 2x minus b is 3 squared. Cool. So that's the main ways how to factor quadratics. There is a way to factor higher degree polynomials, and it's called factoring by grouping. It's very useful, and for the most part, it's going to be useful in factoring degree 3 polynomials. So for example, and it is best illustrated by an example, if we had something like 2x cubed plus 10x squared plus 3x plus 15, we can't use the other factoring methods that we are working with because this is a degree 3 polynomial, right? So what we're going to do is I'm going to sort of group some terms together. That's why it's called factoring by grouping. So what I'm going to do, just because it's obvious, I'm going to go ahead and take these two terms and I'm going to group them together. I'm going to take these two terms and I'm going to group them together. And now what I'm going to do is I'm going to look at each of them and be like, what is a common factor? So the common factor between this term here and this term here, right? What can we pull out from both of them? So they obviously both have some x's in them because this is an x cubed and this is an x squared. So we know that we have an x squared because we can pull out an x squared from this one here. And if you notice 2 and 10 have a common factor. So we know that we can pull out a 2 because 2 goes into 10. So common factors of x squared and 2. and we can combine them to 2x squared. And for this one here, this one doesn't have an x, so we can't pull out an x. But we see 3 and we see 15, and we know that 3 goes into 15. So we know that they have a common factor of 3, right? And the reason I care about this is because now I can take this term here, this first one here, and I can write it like this. I can pull out the 2x squared, and I get x, because 2x squared times x is, 2x squared times x is 2x cubed right here. So that works out. Plus, and then if we pull out a 2x squared from this, the x squared all goes away, and we just left with a 5. And then look at the other one over here. What we get is, if we pull out the 3, right, this 3 goes away. So we're just left with x in the first one, and then 3 divided by 15 is 5. Now you're like, these look the same. And that's good, because now you can kind of think as these things in the parentheses as their own kind of chunks, right? And they look exactly the same. So what we're going to do is we're going to pull these 2 chunks out, because distributivity works with things in parentheses too, not just numbers. So if we pull it out, we get 2x squared plus 3, right? And then when we pull it out, it gets sent to this side right here. And look at that. We have a factored polynomial. Now you might notice I chose to group these in a particular way, but you can group it the other way too. So if we start with our original one, so it was 2x cubed plus 10x squared, and then it's plus 3x plus 15. If we wanted to group it a little bit differently, let's go ahead and swap these 2 out. So let's write this as 2x cubed plus 3x plus 10x squared plus 15. And let's group them this way, like that. Okay. Let's see, any common factors here? Well, they both have an x. They have 1 copy of x. But 2 and 3, they're both prime for one thing, but they don't have any common divisors. So all we have is just an x there. And if we look over here, this 15 doesn't have an x, but 10 is 2 times 5, and 15 is 3 times 5, right? So they have a common factor of 5. So there's a 5 there. So now, if we do this, if we pull out this x from this one, this becomes 2x squared. So we take a copy of x out, plus, and then take the copy of x out there, 3, put the x on the outside, plus, and then if we do, if we pull out a copy of 5, what we get is we have 10 divided by 5 is 2, so 2x squared. And 15 divided by 5 is 3, so plus 3, and pull out the 5 there. And look, they match up again. Excellent. So now we can again do the same thing that we did last time and pull it out to the side, because we can treat the parentheses like just one big chunk. And so we have x plus 5, and then that's times 2x squared plus 3. And that is the same answer we got as last time. So you can group it in 2 different ways, and it doesn't really matter. So that's the fundamentals of factoring. I recommend you spend a good amount of time studying this, because this is important material for later.